Hello guys, and welcome back to another part in my analog DIY synth journey. Right, today what I'm going to be covering is my Advantage 03 system Dual VCA, or also known as a Voltage Controlled Amplifier. In actual fact, there is actually 4 VCAs on this PCB here. So this is the unpopulated version, and this is the version I've populated with some modifications yet again. So this is going to go to a revision, probably a revision 1.1, for I'm finally sort of happy with that. I've had to do a few bits and pieces to that. Now the design itself is based around the LM13700 OTA IC, which is also known as an operational transconductance amplifier, which works different to an op-amp. So basically it converts a voltage to a current, and then you convert the current back to a voltage either via the provided Darlington transistors internally inside the chip, or you can use an op-amp and then you just send that to the negative feedback part and then set your gain to get your output. My reason of choice for using this over a more discrete version was the fact that I kind of wanted to keep the parts count quite low and the complexity as well. If you look down the middle of this board here, if you say split it in half, it's actually both, it's mirrored on each side pretty much. It's just rotated the other way round. There's just a few things, just these trimmers here, which are exactly the same here, which are the, let me think, these are the trimmers for the velocity. Okay, and as we can see under here, we have our populated version. Now don't get it twisted, this chip here is the same chip. It's the NE5517. It's just a variant, it's the same thing. This dual operational transconductor amplifier chip. Right, so, and as you can see, each one contains 2. They're quite finicky to get right, to be honest with you. I've had a few sort of headaches with it, and I've had to further go back and tinker and tweak with it, just due to not being too happy with a few things. So there was a few goals I wanted to achieve with this, which were basically to bring the signal to noise ratio down. I mean, it wasn't terrible, but I just I'm a bit of a perfectionist, and I just really wanted to try and get this bang on. And the DC offset, which was caused by the modulation from the envelope generator. So basically what that means is, so if you'd send a signal through, you would get a bit of a bump every time you hit the envelope generator. It would send the signal up above the 0 line, so you'd hear that sort of that envelope click, or that little bump. So I really wanted to iron that out. So I did have some offset trimmers, which you can see on the board here. And these are going to be eliminated on the version 2 board, because although I've seen this on so many designs, I try to, change values and tweak things through and see, how I could get mine to be spot on, but I couldn't quite get it. So I kind of went back to the drawing board and I built another version here, which is the same as what you'll see on the populated board. And I've put in the values which work well. Another goal what I wanted to sort of achieve was keeping the high frequency content, the integrity of the high frequency content. So what I noticed was that one version I had before, when you listen to the signal before it came into the VCA, for some reason the actual high frequency content was really dull. So I wanted to sort of try and maintain that throughout the signal path. And also distortion as well. These are quite susceptible to distortion if you drive them with too hot a signal. So as opposed to a discrete, you can distort them, but they distort nicely. These ones go into quite harsh distortion and don't sound too great, to be honest with you. So I had to be careful. I mean, say for instance, you're doing things like a very big high pass resonance sweep through, and you get a massive sort of that peak boost from the resonance. It gives you a fat sine wave, and it tends to distort. So what I did with the breadboard here is I managed to just kind of basically put the values together and just trace that signal path through and keep going backwards and forwards and making sure I'd pretty much got everything that I'd achieved everything I wanted to achieve. So the way it works here is what we have is two VCAs basically, which give you your output. So what happens is you pass the signal gets passed through the first VCA, and which is on one side here, and then it passes through to a second VCA. So the first VCA, what happens, it has a switch which is over here. So on one side of the switch we have a constant control voltage which keeps it open when there is no MIDI CV velocity coming in, and then you can switch it over. So if you have a MIDI velocity CV out, which I have coming through here, and I have, I think, coming through this cable from my key step, we can send a velocity. It will respond to velocity depending on the incoming voltage of how hard you strike the key, just in case of those who don't know quite understand how velocity works. So the harder you hit it, the higher the voltage will be, which will open up the amplifier even more, so you get a higher gain. It's good. It just gives you a little bit of dynamics, gives you a little bit of movement with your sounds, and gives you a little bit of expressiveness. Still not 100% spot on, but it's, do you know what, it's really getting there. Yeah, so that's all it is, and then that will pass through to the final VCA stage, which is modulated or opened by the envelope 1, or should I say envelope 2, which is over here, which only deals with the VCA. So that's all there is to it. So what I'm going to do in the second part of this video is basically just do sort of a small sound demo. Oh, I did also forget to mention, I also have an LFO connected up here. So this will come from the LFO that I have, the main LFO board. In the final system there will be two LFOs which will be exactly the same, which give you 5 different waves which you can invert. But it's also good because it works very well with the Wavefolder. I'm sure you've seen the Wavefolder demo before. I will be doing another Wavefolder demo after this video, because the first one I did, I actually used the signal of a mini brute, where this time I will use this Advantage 03 system signal path to show you that Wavefolder demo. So yeah, the Wavefolder responds very nicely to the modulation from the envelope, or you can get it through the LFO for some really interesting sound and interesting effects. And I also managed to tweak this so I had the maximum amount of foldage from the Wavefolder, or maximum amount of saturation from the Wavefolder before it starts to go into horrible distortion. Again, everything, I really had to balance this out right. That's why this thing is not going to be a rushed project. You know, I don't see the point. It's probably maybe the only one I ever do. You never know. See how I get on with this one. All right. Anyway, thank you for watching, people. And like I said, I'll be back on the other side of this video with a kind of quick sound demo, just to show you a few bits and pieces to let you have a listen. Take it nice and easy.